There are three different forms of quadratic functions. They can be written in three different ways, and each form serves a specific purpose. I will go through this full diagram, and then the next slides will focus on a specific example and all the properties. So we're always looking at the form that we have. We will always try and find what we call the vertex, the axis of symmetry, the concavity, the y-intercept, the x-intercept, if they exist, and then we talk about the domain and range. The name of these properties you should already know based on the shape of the quadratic function. So in each of the forms, if you notice, you have these three letters, and each of the letters serve a purpose. They are not the same letters. They don't represent, they're not equivalences of each other. The only letter that repeats and it is the same letter is the a value. So the a value, which is the coefficient of x squared here, is also the a that's in front of this squared bracket. It's also the a in front of the factored form. Another thing to note is that factored form is also called intercept form, and we'll talk about that in a second. So these properties, if we go through them one by one, if I'm looking at the vertex, which is either the minimum or the maximum of my function, then if I'm in standard form, vertex is a coordinate. So in order to find it when I'm in standard form, I have to do negative b over 2a to find the x coordinates, and then substitute into my function to find the y coordinates. Every time you see this notation, f of something, it means you have to substitute this something into your function. I know it looks complicated, but it's just a substitution. If I'm in vertex form, then the vertex is given. It's h and the k value, which is why it's called the vertex form. So as soon as you're in vertex form, you have to take these values, but you need to note that the h value changes signs. It doesn't actually change signs. What happens is the negative is making the sign switch. But just to simplify this and not overcomplicate it, we just say the h switches signs, and then the k, you take it as it is. So you do not need to do any math to find the vertex form. In factored form, you have to find the average or the middle of the p and q value, and again you have to switch their signs when you use them. You have to find their average. This will give you the x coordinate, and then you have to substitute it to find the y coordinate. And then we need to find the axis of symmetry, which is where the graph splits exactly in half, and this is quite easy because you've done it already. It's the x coordinate of the vertex. So it's the h, it's the negative b over 2a, it's the p plus q over 2, so you've already found it in there. But note how it's written. You have to write the axis of symmetry as an equation. The question will ask you, write the equation for the axis of symmetry. This is what they mean. It has to start with x equals. Then talking about the concave of the graph, whether it's concave up or it's concave down. It's concave up if your a value is positive, and it's concave down if your a value is negative. And this is the same for all the forms. The y-intercept, you just need to substitute x with 0. In standard form, this is basically the c value, so you don't need to do much work. And it's better to write it as a coordinate, so it's going to be 0c. In vertex and factored form, you have to substitute 0. So this just tells you substitute 0 instead of f. On the other hand, if you want the x-intercept, you need to make y equals to 0, and then you have to solve. So you need to go back to how you solved quadratic functions and the techniques you've used. So in standard form, we solve it either using factorization or quadratic equation, or if you have a Casio calculator, you can go through mode 5.3, or if you have a TI, you have poly-simultaneous. So there are different ways to find the x-intercepts. If you're in vertex form, you solve by making x the subject. If you are in factored form, it's already given. It's the p and the q value. That's why factored form is also called intercept form. So just like vertex form automatically gives you the vertex, factored form automatically gives you the factors, the intercepts. So you don't have to do any work to find them, but again, the signs switch. So your whatever sign they have, they're switched here. I'm not going to go through in-depth reason. I'm just keeping it simple for this video. The domain of a standard quadratic function. And what I mean by standard, just a normal quadratic function that doesn't have any restriction. The domain is negative infinity to infinity, or all the real numbers. Unless the question talks about a real life situation. For example, you're dealing with time. In that case, time can't be negative, so you will make the domain restricted. But in a general quadratic function, it's just all real numbers. For the range, it depends on the concave of your function. If you are, that's why you'll see these conditions. If you are concave up, then your range will always be from the y coordinate of the vertex to infinity. If you're concave down, then your function will always be from the y coordinate of the vertex to negative infinity. That's why this is written here. I think in vertex form it's easier to see. It's taking the y coordinate and going to infinity, and then negative, and then to infinity. These are meant to be square brackets here for the, just to clarify, to include the vertex. So they're meant to be square brackets in there. So we're going to go through each of the forms, and hopefully each of the properties will be a bit clearer. We'll start with 2x squared plus 4x minus 6. It's good to start by identifying your letters. So A is 2, B is 4, and C is negative 6. We will start with the vertex. We use the formula negative b over 2a to find the x value of the vertex. So negative 4 over 2 times 2. And that will give me negative 1. So that's the x coordinate of the vertex. For the y coordinate, I have to substitute this negative 1 into my function here. So to find the y value, I just substitute negative 1, 4 times negative 1, minus 6, which will give me negative 8. And I want you to get into the habit of writing things as coordinates. So now we have negative 1, negative 8 as our vertex. Then we come to the axis of symmetry, and we said you don't do any work. This is just the x coordinates that you found. So the axis of symmetry is just x equals to negative 1, but I am rewriting it as x equals to negative 1 so that it looks like a equation. The concave of the functions is my a is positive. It's bigger than 0, so we have a concave up. This also gives you extra information that this vertex, if I'm concave up, then this vertex is going to be my minimum value. So minimum vertex. Next, the y-intercept, it's just the c value. So no need to do much work, it is just negative 6. So I have 0 minus 6. You can check by substituting 0 into here. These will eventually cancel out, and you end up with negative 6. The x-intercept, you then can solve this. So again, you can use any method that you prefer. I will just show you how it's done through factorization. In this example, the numbers are nice. I can factor out 2. So give me x squared plus 2x minus 3. And then I can factorize it, which gives me x plus 3, x minus 1. And you've dealt with this type of example before. I can get rid of the 2 by dividing by 2. So I will divide by 2 on both sides to get rid of the 2. And I have x plus 3, x minus 1 equals to 0. Then either x plus 3 equals to 0 or x minus 1 equals 0. So I have two case scenarios, which gives me either x equals negative 3 or x equals to 1. So as coordinates, I have negative 3, 0, and 1, 0. Now keep in mind that in x-intercepts you might get 2, 1, or no intercept. And this goes back to, if you're trying to solve quadratic equation, it goes back to the discriminant. So go back and revise how you solve quadratic equations. This is the lesson to focus on, but I'm not going to focus on it here. The domain is just all real numbers. It doesn't change. The range, again, because I am concave up and my vertex is at -1, -8, then my graph is the range is gonna start from -8 and it's gonna go upward. So my range is from -8 to infinity. This is for standard form. If I'm in vertex form, again, let's practice by finding the values. My A value is 2. My H value, keeping in mind that the sign has to change, it's -1, and the K value is -8. So just to point out on what we mean by the sign changing, it's because the form itself has a negative in there. This negative forced the H value to change its sign. So actually, this was originally x minus the H value, which is -1, -8, but -1 eventually simplifies to a +1, which is why it seems like we're switching the signs. So once I have these three values, vertex is quite easy. It's just your H and K value. So H always represents the X coordinates, K always represents the Y coordinates, and that's always the case. So whatever inside and next to the X, that's your X coordinate of the vertex. The axis of symmetry is just the X coordinate of the vertex, so it's X equals to -1. The concave behaves the same. A is bigger than 0, so we have concave up. The y-intercept, I just substitute 0. So 2, 0 plus 1 squared minus 8. I'll simplify that. I get 2, 1 squared minus 8. 2 times 1 will give me, so 1 squared is 1, and then 2 times 1 is 2. 2 minus 8 will give me a -6. So as a coordinates is 0, -6. Then when I come for solving the x value, I'm just going to solve it here. To solve, I need to make y 0. So 2x plus 1 squared minus 8 equals to 0. Now, in vertex form, it says solve by making x the subject. The reason we can make x the subject in vertex form and not in standard form is because I have a single x here. In standard form, you have two x values, and you cannot make x the subject in that case. So it's better to always be in vertex form for you to make x the subject. So in this case, I will start solving normally, and then I'll divide, and then I have to square root. When I square root the other side, keep in mind that you'll end up with a ±2. Why is that? Because remember that 2 times 2 gives you 4, and then -2 times -2 will also give you a +4. So this leads you to two case scenarios. Either x plus 1 is 2 or x plus 1 is -2. In that case, 2 minus 1 will give you 1, and -2 minus 1 will give you -3. So as coordinates, I have 1, 0, -3, 0. So no need to expand. I know it's tempting, but no need to expand in vertex form in order to solve it. You have a single x in there. You can make it the subject. That's one thing to note. Another thing to note is that when you square root the other side, make sure that you end up with a ±. Now, some students wonder, what if it's not a nice number? What if I end up with something equal to 7 and I have to square root the 7? It's fine. You just keep it as a square root of 7, and then, for instance, you end up with 1 plus minus square root of 7. Okay, so we keep it in what we call surd form. And then the last form, which is factored form or intercept form. Okay. Again, it's called, find the values first. A is 2. The p value, we switch their signs. Every time we see a negative in a bracket, it means the signs have been switched. So we switch the signs. P is -3, Q is 1. Now, it does not matter which one is P and Q in this example, because I haven't specified if one is smaller than the other. Sometimes questions will say P is less than Q, then you have to be picky about which one is P, which one is Q. But in this case, P is just -3, Q is just 1. Now, why is this called intercept form, and why do we use it? It's because it gives you the x-intercept. So when I come to this step, my x-intercepts are just P and Q. No need to do any of the work we've done before. So the intercepts here are just -3, 0, 1, 0. So I've just directly taken these values. So this is why it's called intercept form. This is why it's useful to have all the three forms. Vertex form, we find the x coordinates by adding the P and Q value and dividing by 2. So I'll do -3 plus 1 divided by 2, which will give me -1. And then the y coordinate of the vertex will be, just as we did in standard form, you will take the value and substitute it into your function. So I will say y equals 2 -1 plus 3 and -1 minus 1. So just to note, this is my value being substituted. This is my x value being substituted. This will give me 2 times positive 2. And then -1 will give me -2. So 2 times 2 times the -2 will give me a -8. So the vertex is -1, -8. The axis of symmetry is just what you found here, so it's x equals to -1. Now I'm just going to explain quickly why this formula works. Why are we doing P plus Q over 2? It's because P and Q are your x-intercept. This is when your graph crosses it's -3. This is when your graph crosses the x-axis, so at -3 and at 1. So if I'm looking at the vertex, I'm looking at the middle of those two numbers. Or if I'm looking at the axis of symmetry, I'm looking at the middle of those two numbers. Well, the middle of any two numbers is just you adding them and dividing by 2. Then the concave of the function behaves the same. Again, our a value is positive. In this case, we have a concave up graph. So our vertex is going to be a minimum. The y-intercept, you do the same as we did before. You substitute 0 for x, so we get 0 plus 3, 0 minus 1. And I end up with 2 and then 3 minus 1. There's no expanding here. You're just multiplying across 2 times 3 times -1, which gives you -6. So I have 0, -6 as my y-intercept. Domain and range will be the same. Domain is all real numbers. And then the range, since it's concave up and my vertex is -1, -8, then the range is just -8 to infinity. And the last thing we're going to do is to graph it. So let's just summarize all the values we have. We have the vertex. If you've noticed, hopefully by now, it's the same function all throughout. Actually, we just did it in different forms. So for all of them, we have the vertex as -1, -8. The axis of symmetry is x equals to -1. The concave is up. The y-intercept is 0, -6. The y-intercept is -3, 0, and 1, 0. The domain is all the real numbers. And the range is from -8 to infinity. The reason I picked the same example is just to show you how with the same exact function you can get the different properties in all the different forms. So for all the coordinates, just point it out on the graph. You have the intercepts first, so you have -3. You have 1. You know your axis of symmetry will be here. We tend to do it with a dotted vertical line. So x equals -1. The vertex is at -1, -8. And my y-intercept is at 0, -6. The only thing that might not be consistent in all quadratics is the x-intercept. Sometimes you end up with 1 intercept, sometimes no intercept. Once you have everything, then you connect them all, keeping in mind that you should be concave up. And just roughly, since it's a freehand sketch, should be a bit better here. And this is your quadratic function. function graph.